In this video, we're going to look at a basic statics problem, a really common statics problem that comes up. And statics is where you have a system that's in equilibrium. So in this case, it's a statics problem for forces. You can also have statics problems that involve torque, but we won't look at that until later on in second semester, since that deals with rotation. So for this problem, we've got a mass that's being suspended by a ceiling or by wires that are attached to a ceiling. You need to find the tension in all three of the wires given the mass of the block and the angles. At first glance, it seems like you don't have enough information to solve the problem, but in reality, you do. So anytime you have a force problem, the first thing you always want to start with is a free body diagram. So let's start. And I'm going to draw actually two different free body diagrams. For the first one, it's very simple. I know I have the weight of the block downward. And then the tension in wire 3 is supporting the block and keeping it from falling. And in fact, the tension in wire 3 has to fully support the block because there's no other wire directly connected to that block. For my second free body diagram, tension 3 is now pointing down because wire 3 really transfers that weight, that force, into wires 2 and 1. Okay, so those are my free body diagrams. So from here, I want to write a Newton's second law equation when it comes to all the different scenarios. So I'm going to start with my first free body diagram right there. I'm going to say that the sum of the forces is equal to 0 because that is the definition of statics. So 0 is going to equal T3 minus mg, the weight of the block. And I am making up and to the right my positive directions. So that means then that the weight of the block must be equal to the tension in wire 3. So it's a very easy substitution from there. My block is 30 kilograms. G is 9.8 meters per second squared. So that means that T3 is 294 newtons. So that's the tension in wire 3. And now I'm going to work on finding the tension in wires 1 and 2. Okay, so for the wires 1 and 2, they're at angles. So some of the tension is in the x direction and some of the tension is in the y direction. So I'm going to split that up. And first, I'm going to just examine the x direction. And I know that the sum of the forces in the x direction is also equal to 0. And remember, I said to the right is positive. So that means that T1 times the cosine of 50 degrees. So as we see in this problem right here, there's my T2 x, and the angle is 50 degrees. So that's why I'm using cosine of 50 degrees minus T1 cosine of 20 degrees. So there you see then I have, there's my cosine of 20 degrees, there's my T1x. Okay, so then I can just add T1 cosine of 20 to both sides. That's going to equal T2 cosine of 50. So they have to be equal and opposite in order for the system not to move to the right or to the left. And then I'm going to actually solve for T1 in terms of T2. Cosine of 50 degrees over cosine of 20 degrees. Okay, so now what I'm working towards is getting everything in terms of one tension ultimately. So that way, because if I can solve for the one tension for, if I can then solve for T2, I can go back and solve for T1. So now let's keep going. And now let's look at the forces in the y direction. In just the y direction, they're equal to 0. And let's go back up and look at my free body diagram. So this time I have T3 down, I have T1 in the y direction up, and also T2 in the y direction pointing up. Okay, so I've got to take all of those into account when I go to solve this. And again, up is positive and down is negative. So that means that I have T2 sine of 50 degrees plus T1 sine of 20 degrees minus T3. Okay? And then the next thing that I'm going to do is I'm going to substitute in for T1. So I'm going to take this right here. I'm going to plug it in there for T1. I'm going to move over a little bit so I've got enough room. So 0 equals T2 sine of 50 degrees plus T2. Well, sine over cosine is tangent, so I can write tangent of 20 degrees times cosine of 50 degrees minus T3. I can bring T3 to the other side and also substitute in for the T3 value because I solved for T3 right here. So now I know that 294 newtons equals T2 sine of 50 degrees plus T2 tangent of 20 degrees times cosine of 50 degrees. So now I just need to plug in for my sine of 50, tangent of 20, cosine of 50, plug it in my calculator and solve for T2. Make sure your calculator is in degree mode because otherwise you will get a wrong answer. And you actually end up finding out that sine of 50 plus tangent of 20 times cosine of 50 is 1. So that means that T2 is also 294 newtons. And so now we're going to take this value and we're going to plug it into this equation up here. Ooh, that's a fun effect. And find T1. Okay, so now we're going to say T1 equals 294 newtons times cosine of 50 degrees divided by cosine of 20 degrees. And we find that T1 is equal to 201 newtons. So it's really a systems of equations problems using Newton's second law. If you have any questions, make sure that you contact your instructor.